All right, let's get it going. Let's do it. Hey, I'm Eric. I'm making a game. It's called The God Killer. It is a 3D, top-down puzzle solving game. And in this game, there's a camera pointing down on your head all the time, and you're just a little speck in the world. But you got to go and figure out that world that you barely know anything about, and solve puzzles in it, make progress, and go up against, dare I say it, the greatest enemy that has ever been put into a video game by some measures. You can always add that to the end of something. You can always say, this will change the world as we know it. The greatest of some of the time, not all the time. So I'm going to demo this in just a moment after all that fanfare, and you'll look at it and say, yeah, that's kind of cool. That's all right. To me, it really is going to be fucking awesome. And you may not quite be able to see exactly why quite yet. I'm just kind of slowly unveiling the greatness of this thing just a little bit at a time. It doesn't look like a great game yet. It looks like, maybe that could be interesting. That's what it looks like now. When you see it, maybe. When I see it, I see the path. I see the path from the current point all the way to a game that's released that people will remember after they played it, and they say, oh yeah, that was that one game that I wasted a couple months on and obsessed over. Now, I may sound like an asshole to come up with proclamations like this, but I've done it before. Now, I don't claim to make games that everybody likes. What I do claim to do is make games that a small number of people, a small portion of people, just enjoy the shit out of. And this is going to be that type of game. So let me show you what it is. Okay, I've got to resize my window a tiny bit. So that you can see things framed in the broadcasting space, I'll call it. I had it all full screened, and it needs to be just a tiny bit smaller so that there can be space on the side for a chat window. That's debatable. I'm not getting a lot of chats these days. But no, I want to allow for the possibility that someone might pop in and write a few words there, and then you'll see it on the screen as it happens. Okay, so looking at the screen here, you see this small little figure down the middle. That creature is called M. That's your character that you control in the game. You get to move around, and I'm not going to explain every single thing about this game right now. What I'm on about at the moment is this character in the game called God. Not your God, just a God. God of this world. God of everything in this reality that the game character lives in. And what I've managed to get it to do at this point is smoothly rotate to face the character wherever she's at, the main character. And it's got, some acceleration, and it's got stuff in it that makes it rotate, kind of like you'd expect your basic floating hands to do. Every time you've seen floating hands, it acted a certain way. The other thing is, you've seen it snap all the way down, or all the way south, as I call it, since we have to play with 6 directions in this world. So there are predefined places called stages, or hand stages, where I decide it's okay for the hands to be, that they'll be able to have enough space around them to fully do all the things that I plan to have the hands do. And in this room that the character's in, there are 2 hand stages. There's one on the south end of the room, where the hands are at now. And there's another hand stage up north, on the north end of the room. So it's just flitting in between these. And I have like a graph defined, which says all the hand stages that are in the level, they're connected in certain ways. And the hands may go along those paths in that graph, or they may go from one connected node to the next. So I go down here, there's another hand stage where the hands just flitted to, not smoothly, coarsely, all at once. They teleported. My intent, which I believe I will accomplish in this session, probably within 2 hours, is to have them smoothly travel in between the hand stages. So it looks more like those hands are in the physical world of our character floating through space. So I've shown 3 hand stages. There's a 4th one there. I'm going to add some more hand stages to it. As the character walks up steps, there's also the ability for the hands to move vertically up as well. I'm not sure if we'll see it. I think she's a little... Oh, there it goes. So, okay. See, so those hands, they can also move up and down. But a key point is they're moving to pre-specified nodes. The other part that I haven't explained too much in this particular recording is that the hands will later on have an animation played for their individual parts that causes hand gestures to be performed that correlate to an actor's speech, which will be dialogue that will be played back. So you see an actor talk and his hands will move and it will look friggin' cool. It'll look good. It's gonna look good. It's a part of animation that we a lot of times we miss in games, is good hand animation. There are so many things that can be done with hands, with expressing emotions. You can obviously you can do basic things like put your hand in a fist. That's aggressive. You can point. Now, if you ever watch somebody that does like a lot of gesticulation, there's a whole vocabulary to it that's very subtle. Just things like, on one hand, this happens, and on the other hand, your hand will move off over there. When you talk about things that have a spatial element to them, even if it's not literally spatial, like if you're making 3 points, you might say that. You might just point out the actual bullets of it. There's many kind of subtle, nuancy hand gestures. If you ever watch somebody, they say all of the time. They might have a big sweeping motion as they say all of the time to include everything. There's tension that's communicated with hands and fingers. All kinds of nice things that we're going to capture in a live actor's performance and play back through these hands, and it's going to look great. It's going to look great. And at the moment, my job is not to do that. It is to just get these hands to move smoothly to and from whichever stage they've been appointed to. So I'm going to hit the unplay button on this baby. Now, if you're watching this as a recording and you're thinking, it might be cool to come in on a session and chat along with Eric as he's working on this stuff, let me say you are more than welcome. I would love it if you would do that. And let me go back to my big stupid head. And there's a schedule here underneath. It's also at the bottom of the Twitch channel. You could be seeing a recording on YouTube. Where I broadcast this from originally is not YouTube, it's Twitch. There's a link in the description to the Twitch channel. You can go to that. When am I going to be live? Pretty reliable on this. Monday through Thursday, 6 to 8 p.m. I do these live coding sessions. I always start them off with a demo, just like the one I just did. And then I go into the more contemplative work state where I talk less, though I'm still pretty verbose, and I actually get shit done. And yeah, it's a little, you can see me get a lot more mellow in just a moment as I start doing that. Now, if you don't like coding, if that's not your jam, then join me on Sunday, 3 p.m.ish, in the afternoons, all in the Pacific Standard Time. And there I do level design and art and sound, some kind of task that's not coding but still game development. That's what happens on Sundays, in the Sunday afternoon. And it's very pleasant. And you're welcome to join me. Now back to the game. So here I am in the Unity editor, and this is the design view. We're not in the game, or I should say it's the editor mode. It's showing the scene, and you see like these little yellow dots here connected by lines. Those are the center points of each hand stage. So if I just pick one of them, if I can do that, hand stage 1. Okay, so that's the one over here. And there's another one over here. Can I click on it? Just by clicking on it like that. I can. Okay. So there's two, like I demoed earlier, on both sides of the room. Each hand stage has kind of a blue box around it. I might do something where I make the box be white if it's not selected, or some other color, so you can see more clearly which one's selected. But the boundaries of this box are pretty large, 9 meters by 9 meters width and depth by 4 meters height. So I need all that space so that I can say that it's not going to mess anything up for the hands to rotate around inside of that area. It's not going to like have them kind of ghost their way through some other scenery in the some other meshes in the level. So it's pretty large. Then there's these connecting lines between the hand stages. Those are calculated automatically. Which neighbors are closest. So from this hand stage, it travels off to another one over here. And then a little bit further, it comes over to this one that's over a pit. And then there's another hand stage that's above this other one on the pit. That was the vertical movement that we saw earlier, where the hand was snapping up and down. I can make as many of these hand stages as I want, and paths are, I'll do that right now, I'll show you. Paths are just automatically calculated in between them. So you can kind of see I made a new hand stage off over here, and it's not just necessarily one linear progression from one to the next. I can also drag off in the other direction. And so there can be like more than one way to get to it, or I should say there can be forks in the directions that the hand can go. And those are all just created automatically as I add hand stages. Don't have to connect them manually. So I want these hands to travel over time to the, I'll call it the target hand stage. And I already have code that sets the target hand stage. I just need to add that code that sort of nicely moves them over. So I'm going to do that right now. Right now. See, I even got a to-do right here. It says add smooth movement. I didn't want to forget. So down underneath here, I've got rotation. I say the target because I've abstracted it, but almost always it's going to be the player. But it's possible I could set the target to something else, and that would be fine. So Okay. So at this point in the code, this value here, hand stage, is going to be whichever stage that I want those hands to be at, the one that is closest to the target. So next I want to move towards current hand stage as needed. I might already be there. I might not need to move at all. And I'm a person who does not really mind, in certain cases, having a function which has a lot of stuff in it. I think it's a little bit silly to say you always want to have short functions. I tend to say if there's like a logical concept that's easily expressed inside of one function, that's a good time. Now if you create that function and you end up having to pass 8 parameters to it, then I kind of go back towards, let's just stick it in the main function. Okay. Now if you intend to reuse that function for more than just the one function it would be called from, then I go back towards, oh, let's refactor. Let's go ahead and refactor. But I don't automatically break up a lengthy function. Okay, so what do I need for this? I'm going to need some constants. They're not constants. I'll say they're tweakables. They're inspector properties that we can set inside the inspector. But other than that, they shouldn't be changed. So let's call it let me follow the same pattern as I did for here. I'm going to rename this to something more specific. Okay, so I did that because I'm going to have more than one acceleration. Kind of the same thing here. I'm going to have, some tweakables that correspond to rotation and some other tweakables that correspond to the position. Okay, so I can kind of model my logic after the logic I already created. So I can do float, top, let's call it move, accelerate speed. What's a good top speed? 4 meters per second. That's a pretty good clip. Okay. Okay. Good. Do some design here. Okay. So I'll have start and end vectors. S and E. It's a little bit more complex than the rotation, I think, because it's not just one linear deal. I suppose I could use the built-in stuff. It's more physics than I want. I think I could do this much simpler. I could just do something like that. Then I'm taking out the idea of a top speed if I do that. I would just be saying move between the 2 points at some spot between 0 and 100%, which is the smooth factor. Okay, so distance from S to E. Distance from S to E. Ideal speed equals D okay, I also need a taper distance. I'll start tapering once I get within 4 meters. Ideal speed equals D less than the taper. And it's going to be scale equals scaled by taper or top move speed. Okay. And figuring out the actual speed that I'm moving at. I can keep that, I can store that from the last one. So prev, that's it. So accelerate to ideal speed, if not capped by the top accelerate speed. So I'll say accelerate towards ideal speed. The thing that complicates this a little bit is, say you're in a car and you're moving north. Or just say your hands, your floating hands, which is the thing I'm actually trying to animate. You're moving north at top speed 4 meters a second. But suddenly your target changes and you gotta go the opposite direction. So you were going this way towards target A. Suddenly you have to go towards target B. According to my algorithm here, I would still want to continue traveling at that top speed, because I may be far away from both points. The ideal speed would then be 4 meters per second, but I can't turn on a dime. I can't just, well, I don't want to. It'll look bad to have X suddenly just moving in the opposite direction at 4 meters per second. So I could say, well, just also add in like directional momentum to that, which is what I'm going to do next, but I don't think I can do it easily just with the angle. I think what I really want to do is track like X and Z movement. So if I have a dx and dz, I could cheat a little, and instead of making like this acceleration, all these caps and speeds applied to the angle that you're moving at, I could say it just applies evenly to either X or Z movement. And that's like a little bit off, but it's a lot easier to think about, a lot easier to do the math for. So I think I'm going to go with that. I'm going to move, like, even though I want to put them back up here after a bit, I want to move like all the variables and apply to my code in question down closer to my implementation. So let's go public float move, let's see, prev move dx 0 prev move dz 0f. Yoink that. Maybe I'll yoink the comments too. Just have it all in one space so I'm not jumping up and down a lot to reference things. Okay, take all that, put it down here. Okay. Alright, so I'll start doing some of this stuff. Calc the distance between the 2 points. I'm kind of going to go against what I said earlier. This does seem like a great thing to encapsulate now. I'm forgetting some of the reasons to do it, but okay. Move towards hand stage. I can make this even more encapsulated. Move towards point. And I'll pass in the hand stage position, which is vector 3. Distance is pretty easy to get. Nice built-in function for that. Don't have to do three-dimensional Pythagorean theorem. I'm just going to do a trivial check here to see if I'm already just so close to it already. I'm not going to like keep on whittling down that extra space. So I'll say if I'm less than 0.01 f, which is like inch, a centimeter, I guess. It would be a centimeter in unity world space. Just exit out without doing anything. We'll call it done. Close enough. Okay, next stuff. I want to calculate my ideal speed. Okay, so if my distance is less than... Oh, I moved down the wrong stuff. I'll just go get the other stuff I meant to bring. These apply to rotation. I want the stuff that applied to movement. The rotation stuff already works, that's in the done pile. So, just working on the movement of these hands. Okay, let's put this up here so I can see it, reference it. Okay, distance is less than the move taper distance. That's where I slow down. I start slowing down. Then I'll say that I'll have a ratio, distance divided by the move taper distance. That'll give me a number between 0 and 100%, a ratio. Multiply that times top move speed. Okay, that's for the case where I'm coming to a slowdown. Otherwise, I just say, well, the ideal speed is fast because we got a long ways to go. Top move speed. Okay, what else did I say in my little algorithm? Accelerate towards the ideal speed, capped by the top acceleration speed. Okay, so I've got two little doodads here to think about. My x-axis movement and my z-axis movement. And I'll just apply the same transformation to both of them, I think. Okay, so let's say I can make this directional. So let's go float ideal x speed equals I want to get like the direction that I'm going. So it's going to be math x sine of, we'll say 2x minus from x. So this will give me either -1, 0, or +1, and that'll be kind of like a multiplier for this speed. So I'll actually be translating it into not really a speed, an offset, or delta. Delta, that's better. Ideal x delta. So that's saying we would like to be traveling this fast in this specific direction on the x-axis. That's what we would like. You can do the same thing for z. Let's say we would like to be traveling like this on the z-axis. We really would like to be doing that. So then, in order to get towards that goal, I need to move the current delta towards it. So I'll just do one at a time. Break this into two sections. So if basically the distance between the current delta and the one we want to be at is greater than the maximum acceleration that can be allowed, then I'm just going to accelerate by the maximum amount. Which is that times x direction. I'm going to make a new variable so I don't have to put this little bit in twice. X direction. Okay. What are you complaining about? Oh, I forgot to add. Okay. Otherwise, we just say, go for it. Just go ahead, move exactly as fast as you want to move. It's fine. We're not accelerating too fast in that case. Okay. So then I'll do something that's very not dry, and I'll just copy and paste all this stuff below, and then rename variable names. Okay. Let's go. Z. This is Z. This is Z. It's all just making X's Z's. And now I'm kind of happy that I moved this off into a new function. Okay, so then what? I've got a new set of deltas. Except I've already assigned them to this. Is that a good idea? I don't think I need prev anymore after this point. So it probably is just fine. So this is meant to hold the previous delta that I came up with. But when I get to this point in the code, I think I've lost the need to keep tracking the previous delta. So it's okay to directly assign the new delta I want to this prev value. It does kind of make me think, doesn't really make sense to call these prev. Might as well just kind of think of them as the current. Yeah, I don't know why I called them prev to begin with. Okay. So I feel like it's going to do something interesting, but there's a good chance it'll be all fucked up. But that's okay. That's okay. It's going to be fun to watch, I think. So let me abstract this a little bit more. We have to return the new position that we want. So, oh, there's one other thing I got to take into account. But anyways, what I said still holds true. Calc position towards point. So right now I could just say return and then add those deltas to it. That's not quite right, not yet. But also let me change this to be a little more abstracted. I can do from here. That allows me to yank out all the stuff that's specific to reading to or applying to transforms. So this becomes a pure math function at this point. Here it is return 2. I'll return 2. Okay. So the other thing I need to take into account is the amount of time that has elapsed. It's going to be float time delta. Okay. So new vector 3. This is going to be the new position now. The new position that the hands are going to go to, which could be a gradual smooth movement if I'm lucky. Let's say X. X is going to be the old one plus move dx times okay, so the speed I've got here is meters per second. Time delta is going to be number of seconds that have elapsed since the last frame update, so I can just multiply it. From y stays the same. Oh, it doesn't though. I'm going to have to do y too. For now, I'm just going to leave it the same. So I will need to also add like similar set of logic for y as well. But I want to just make sure I get that logic right before just creating a whole nother section for it. So let me just make sure that's correct before I do that. Okay. No doubt I'm missing a number of things. Let me make this 2y. Just for now. Just for now. That's an ideal speed. Okay. I feel like I'm missing something extra, but I'm going to move to the point where I can see the code working, because that will probably get me towards the correct solution faster. So new position equals, and I renamed the function. Now it's called calc position towards point. Okay, and I pass into it from and to. So the first param would be where I'm at now. From the position there. And the next one will be time, delta time. I think that's it. Make it consistent by doing this. Okay, and then with the new position, I need to update I gotta just set that to the new position. So this is the point where I'm 100% sure. No, I'm like 82% sure that it's going to be fucked up in some way, but it'll still be interesting to watch and perhaps provide me with insights. So I know for sure I got to fix Y. But I think it's gonna do something interesting, if not correct. So I'm waiting for the Unity build, which kind of kicks in automatically but slowly after I've made changes in the file system. I'm just fiddling around in the scene until Unity build happens. Oh, there it is. There it is. There's my Unity build. Waiting for that to complete. Get finished. Alright. Seems a little impatient of me not to go through the debugger and all that new code. Seems kind of foolish. Okay. So, some part of the code where it says don't move if you're already right there is working. So there's rotation here, but the rotation is not the new part. The rotation is all in the done pile. That works. It's the movement from one hand stage to another on the XYZ without rotation. So pretty soon it's going to switch, and I'll watch it. It's not switching. It's not switching. Okay. I thought I was at least going to see something cool and fucked up, but I didn't see anything. Alright, so that means debugger. I gotta see what's going on in the debugger. Gotta know. Gotta know. Gotta know. Alright. I expect the distance will not be 0. I think it'll be fair distance. Yep, 3 meters. So it's saying go from one hand stage to the other. That part is correct. So from, yeah, and then the other one's going to have a different Z value. Yep, that part's right. My ideal speed. So I said the taper distance is 4 meters, and I'm 3 meters away. So I expect my ideal speed to be something a little bit less than 4. It might be 3. Let me just see. What did I get? Yep, 3 something. Okay. So far, so good. My direction of movement on the x-axis, I think, will be 0. Because it seems to be lined up on Z. Oh, it's -1. Okay. So 2x. Well, I already know there's something incorrect here. Because I shouldn't be moving at full speed on an axis where I've just got a tiny difference there. So that one, so maybe multiply by cosine. I'm just leaving a note for myself to come back to. Sine, take into account direction. Same thing for this one. But still, that's a bug to come back to, but it's not accounting for no movement at all yet. Ideal x delta. Okay, it's saying move at a pretty fast speed, too fast, in the west direction. Okay, so if the distance between my ideal x speed and where I'm actually at right now is greater than the top acceleration speed, it's not, It's not. It should not be. Wait a minute. 3. Yeah, it's not greater than. It's going to be. Oh, it is. It is going to be greater. Okay. Okay, so that should be true. It is. Okay. So you're going to say move the top speed permissible, 0.1 times the direction. -1. So it should be -0.1. So move a decameter. I think that's what they're called. Like if you divide a meter into 10, I think it's a decameter. Move a decameter. Okay, and Z direction. That should do something though. Maybe it's too small for the time. No, that should still do something. That should still do something. So Z, it's going to be similar. Yeah, it might be pretty close to the same. Okay, so from X right now is at 29, and it should change to 29.1 or something like that. 28.99. Okay, so that's movement. What about this one? Yep. So that should constitute movement. So far, other than an error that I figured out, it looks right. So the new position will get set here. Wait a minute, what happened there? Because there was, oh wait a minute, if I do this, no, it's still got it. It's still got the position there. Okay, so that should have done something. What I'm going to do, because I don't see enough of a change here for it to be reflected visually. I'll hit play. I'll let it go through again, and this time it should have like a really large distance because the delta time is what? 0.1? Delta time is still 0.1 after all that? So this, I expected to be larger. I expected it to be the length of time between the last update, which would have been much larger, I would have thought. Weird. Is it always just 0.1? Maybe it's doing something where in the editor, yeah, I think that's what it's doing. I think Unity's time scaling because it knows I'm debugging, so it's not counting all the time inside of the debugger as part of the scene time. I think it just stopped time while I'm in the debugger. Okay, but 0.1 is actually a fair amount of time. That's 100 milliseconds. Or 10 frames per second kind of frame rate. So that should still be doing something. Let me see, now that I've called this 3 times, did it actually move anything according to this? New position. .9. I gotta like make a note of this. 28.99. .812. I just want to see, is it doing any kind of update on this? So it's kind of acting like I haven't told it to do anything, but I have. Okay, it is changing. 29.00812. It's changing. Hit play again. 28.9. Yeah, but then it went back the other direction. It's kind of flipping between two values. Okay, I know why X would go back and forth, actually. X goes back and forth because it's sort of like oversteering. Like if you're driving down a highway, you're going left, and then you start hitting the shoulder on the left, and then you go, oh, okay, I gotta go back the other direction. So you go right, and you kind of drive off on the right-hand shoulder. So X, I understand. What about Z? That's the value I should have recorded. We should be making progress towards Z. So it's at negative 30.015. Negative 30.015. Negative 30.025. Okay, this is looking more correct. Yeah, this is making constant progress. So just go on that. I'm wondering if I've got the friggin' static flag set on the hand stage. That would be a pretty good explanation for it. When I go back to Unity, it's probably going to be exactly where I had it. Yep, so the hands are still up there. They're not actually moving. They're not. Are they? Wait, are they just going really slow? I can kind of see them going X, Y, X. Oh, they are moving. They're just moving like extremely slow. Extremely slow, because they're not. Okay. So the oversteering go on the x-axis, I can see they're going and Z, it's coming. It's coming like the slowest zombie that ever lived. And now it's settled. So it did actually move towards me. It's just it didn't accelerate properly, and because I've got this faster movement with the rotation to distract me, I impatiently thought it wasn't moving, and it was the whole time. Okay, so it's not properly accelerating. I'm just trying to decide if I want to look at that more in the debugger now that I have it up and going. To see what do I hope will happen and what's actually happening. Okay, so this just needs to be plus equal, and this just needs to be plus equal. I think that's it. I think that's all it is. But that requires a rebuild. Alright, save that. Unity build. Start anytime you want. Anytime. Anytime. You could just start. There you go. Wake up, Unity. Do your thing. While I'm waiting for this to start up, I'm actually kind of thinking ahead to the next changes I want to make, which are scaling the X and Z deltas so they actually correspond to like the direction of movement, and then also adding in the Y delta logic too. Okay, so there we go. And you kept going. No, are you coming back? You're coming back. Whoa. Oh, man. Are you just like flying past it out of momentum? And then you come back? Do you just have too much momentum? That would kind of make sense, because I gave it like this tiny bit of acceleration. If I gave it a pretty large top speed. So I think it's just kind of flying way, way past, and then trying to come back, and then flying way past. Let me just see what else is going on. And then it just flew way past over there. Hey, will you come back? Are you gonna come back? Yeah, there you are. It's like a swinging pendulum. I don't know if it would ever come to a rest with its current settings. No, I guess it is. It is kind of getting a little bit shorter of a duration. Okay. It's out of control though. A lot of stuff to fix there. So first thing are the tweakables, I guess. Okay. I'm not even going to worry about Y until I get X and Z correct. I could even comment out X. Nah. Let's try to fix as much as I can together. So this, I'll just say top acceleration speed can be more. The top move speed will be less. Make it 1 frame per second. I think there's something else going on there too, but it's one thing at a time. You know what? I think I will take out the X, just so I can see what's going on very clearly. I'll make this 2X, and I want to see things clearly, so I'm also going to take out the rotation. I know the rotation works fine. It's just a distraction right now. So the other stuff I wanted was I don't want it to go flying past the point like that. I don't think it's quite just the values I put in up here that are affecting that. So think about it. First I'm getting the direction. that I want to move in. That part's fine. I get the ideal delta. For my case right now, it's moving along that z-axis, so this code is correct, but at some point I want to scale it. Let me see. So there's from. There's also from rotation. I'll pass in some Euler angles there. So let's just specify on X, Y, and Z what the rotation is. So I think about Z. The ideal speed should be based upon rotation along the around the y-axis. It's going to be the sine of from rotation y. I think this is right. Although that's an angle specified in degrees, so I have to convert that to radians. And I'm just forgetting offhand. What am I doing? Dividing by 2 pi. There's probably a function built in. I should use that if it's already there. So I'm just going to look up real quick. Unity, degrees to radians. Yeah, I'll use that instead. MathF, deg to rad. What? Oh, it's just it's a constant. Okay, got it. From rotation y. So it would be like 1 divided by 2 pi or something like that. Okay. Okay, what else? Okay, so then we got to, okay, so that should possibly fix the problem of this not scaling for whatever direction we're pointed in. Just while I remember it, I guess I will copy it over up top as well. There's an issue with that code already, though. It's not the angle of rotation, because those hands are like a spinning plate. They could be rotated many different ways. I can't use rotation of the hands. It's the angle of travel. So let's just call this angle of travel. This will be cosine. That feels wrong too. Anyways, I got off on a tangent because I was gonna come back and solve that, and I thought I could just solve it real quick. But the first thing I need to look at to do angle. First thing I need to look at is why I'm accelerating past the point. So the delta here, it's going to be specifying, like, on the z-axis, how fast would we ideally be going, including the direction. And I say that's already gonna taper up here. Okay. I think I just thought of a totally better way to do this. A much simpler way to do this. I think. So what if I went back to this idea? Calculate time it should take to travel from starting position to end position. Okay. And then okay, and then store starting time on up. Okay, on change in target. Do that. On update, calculate time elapsed since starting time, since start time. Okay. Alert from, okay, and this is the start, not just where you're at right now. Start to target, or I guess end, and then this is a ratio of time elapsed since over the travel time, total travel time. Ratio. I think this is how to do it. I really think this is how to do it. It's going to be a lot simpler. So much simpler. I don't have to think about acceleration. Okay, so you take out this. I know that won't help me. In case I'm completely wrong about this, I'm going to retain the old function and call a new one. Okay. So things I want to know. Did my target change? have to do floating point calculations. This code down here is basically doing that. So okay, so down here, let's hand stage equals neighbor. Start position equals where I'm at right now. Start then move time equals, so total move time, it's going to be the distance between the 2 points. Start encapsulating some of this. Get position and then current position. And then okay, so this could be like this: float distance, distance to target. I do want to track my target position and check for it to be different. So let's call this if, oh, right. if I compare two vectors, is it going to actually look at the x, y, and z, or is it going to... I suspect that it's going to look at x, y, and z. So I'll go with that. Could be wrong. In this case, okay. Just gotta say all those. In the, let's see. So those are the 4 values that I'll need. Okay, then well, I mean, it's not even worth calling a function. It is vector 3 lerp. Oop. Just double check that lerp code. I mean, is that just gonna do a linear movement? between the two with no... Maybe I want slurp? I could try lerp first just to make sure it works. I can smooth out the endpoints of it too without manually if I have to. So yeah. So T would be the, let's see, travel ratio. Time, start. Move time divided by total move time. Okay. So I also need something that indicates that I should be moving. Say if start move position is not equal to end move position. So I feel like this is most likely going to give me like a linear movement without like a speed up or slow down at the beginning. That would be an okay starting point. I definitely know how to smooth out the beginning and end of it. I think I do. A lot of times I'm very certain I know things and I find out I actually don't know them. That happens. Come on, do your build. Do it. There it is. I don't, okay, good. Yeah, I want the breakpoints to go first. I don't want to see what happens without seeing the breakpoints first, or the debugger code. Okay. So I'm also curious if this is always going to be true. I'm not sure if it's doing an instance comparison or if it's actually looking at X, Y, and Z inside distance. What do I think? 3 to 5. 0. Okay, that's not good. Oh, I haven't moved away from the first hand stage yet, so it is pointing right back at the one. This code here is saying where the hand stage is now, that's where it should be. So I should probably add some code here that says if the distance to the target is less than 0, just don't worry about it. Okay. And then this is going to say distance to target 0 divided by top move speed. It's going to be 0. Total move time is 0. Okay. Yep, goes in. Travel ratio, I think. Oh, it's going to be a division by 0 error. See what it does. No. Well, yeah. Division by 0. So this gives me garbage and the transform to garbage. Who knows? Undefined right at that point what it's actually going to do. Might as well stop it and fix that. Okay. Oh, stop it. I don't know what you think you're doing. Just stop. I see. That's a good point. Okay. So I'm thinking that there should never be total move time of 0 here. Floating point's kind of weird. This is incorrect. I can fix this. Okay. Like, it'll give me a division by 0 error there pretty reliably. But if I say, and total move time is not equal 0, because I don't want that, immediately I get this little warning. It says, yo, you're comparing floating point, which is kind of irritating to me because it's like, floating point, even with floating point, you should always be able to say absolutely something is 0 or not. Just the representation of it is capable of saying the value is definitely 0. So I don't like that warning that it gives me. Alright, I think this is okay. Set this. Let me set this. Okay, but is this going to cause a problem here? If my starting move position is not my end move position. Okay, I just need to have an end state. Or I could say feels shaky, but well, let me just start by trying it. Okay. So it came here before anything was initialized. That's already bad. Yeah, I shouldn't do that. Alright. I think my problem here is I'm trying to use all these variables to just imply a certain state, which is, are we moving or are we not moving? So instead of doing that, I'm just going to have an explicit state. Oh, come on. Jesus. Stop whatever you think you're doing. Okay. Is moving equals true. Okay. I'll say if is moving. And then we'll say it's moving equals, and then I'll just check. I keep on like just not trusting this equal check, so I'm just gonna write my own just real quick, so I just can rule it out. Because I just don't trust floating point. I don't trust a number of things. A vector 3. B. This is not true. I assign it down here. What are you talking about? Okay, anyways. So So my breakpoints were off when I was trying to set them, so I just did a rebuild here just so I can get my breakpoints going in a good place. Still off. Just gonna stop that. Hopefully that fixed the breakpoints. Yeah. No. Why is it going down here in the comments? Ah, that's annoying. Okay. Stop. Clean it, I guess. There. Wow. I don't get it. What the fuck is that? Yeah, I don't get that. Is it because Unity is still playing? Is that it? No? Alright, let's see what it does. Cool. That's correct. Oh, there's a breakpoint that was in the right spot. Get rid of this one, which is useless. Alright, anyways. Okay. So that's all good. It's doing what it should do right now. Nothing's moving. So I need to... Yep, I want to get rid of you. Never asked for you. Now you're not letting me get rid of you. Let's see, you're at 159. Okay, go away. Go away. Ah, weirdness. And not the fun kind. Okay, now you're playing, right? Okay, so now I want to see if I can trigger the other logic by moving a distance away. So if the hands will... Yeah, okay. Okay. That should be more than 0. Good. Okay, now we're moving. Somewhere between the 2 points. Okay, time, that minus the start of the time. Oh, well, we just barely began, so it's true. The travel ratio should be at 0 here. On the next frame, however, it will be somewhere else. New position, 29, 35, 28. And the start is 29, 30. Okay, that's all good. Let's hit play, let it come back to the next frame. Now I should be further along. Yep. New position should be someplace different. It is. Okay, I'm going to see what it actually looks like. It's moving. Okay, I'll go back up. Okay, so that's just a linear movement, no smoothing. I'm not necessarily worried about that chunkiness in the middle. I think that might be broadcasting frame rate stuff. Okay, let me just see how well it does with the other hand stages. Okay, it's correctly going to the hand stage that I set for it. So now it should come over. Yeah. So far so good, it's doing fine. It doesn't have any kind of slow down, speed up type behavior yet. So next I'll see if it'll come up to the wild. It looks like it went up. Let me check. Alright, it did a little bit of pathfinding too. It came over. Basically, it traveled 2 hand stages to get me, not just to the next one. So it's a little bit hard to see. Okay. So it should be waiting for me over here. Did it come over? Yes, it came over. Okay. So here's what I'm thinking. I got it moving. I did get it moving. I feel pretty good about getting it to like taper, like to start a little bit slower and end a little slower. But I'm gonna do that off stream because the task of evaluating it for how well it's doing is hampered by my being on stream, because the frame rate is just dog shit while I'm streaming. That's the sad reality of my particular configuration. I'm CPU challenged there. I'll be able to see it better off stream, but if you come back to the stream, normally I don't do any streams on Fridays, but I am going to do a real quick one at 6. I'm going to prove it to you. If you come there, you'll see smooth hands moving around at 6 p.m. Mañana, Pacific Standard Time. That's when I'll resume this with a quick demo showing smooth movement, which I'm probably going to resolve in the next 15 minutes off stream. Alright, thank you for the people that joined. I really do appreciate your presence. Do like an audience, and I hope you have a good day, evening, night, wherever you're at, and see you later. Stopping the stream, stopping the stream, stopping the stream, stopping it, stopping it, stopping it.